Let's talk about lesson 3.1.3. It's called Connecting the Dots. And what we're talking about is what are these lines representing when you look at a structural formula? And so if you, instead of lines, draw 2 dots for each of the lines, and you blow it up even further and separate out where the dots came from, you'll see something that looks like this. Carbon's got 4 dots and hydrogen has 1 dot. So what the heck do the dots represent? Well, they're valence electrons. And there's a certain way to draw something called a Lewis dot symbol. It's where the valence, or it's how many valence electrons that atom has. As a reminder, in order to figure out how many valence electrons an atom has, you look at its group number. For example, everything in group 4A here, like carbon and silicon, have 4 valence electrons. Everything in group 5A, like nitrogen and phosphorus, have 5 valence electrons. Everything in group 6A, like oxygen and sulfur, for example, have 6 valence electrons. Everything in group 7A have 7 valence electrons. And everything in group 8A have 8 valence electrons. So let's go back to drawing them. There's a special way to draw them. Let's say you have element X. Imagine that there are 4 sides and that you have to go in the clockwise direction. So like north, east, south, west. The dots, the valence electrons, want to spread out before they start pairing up. So for carbon, 4 dots because it's got 4 valence electrons. Nitrogen, 5 dots. 1, 2, 3, 4, 5. Notice that there are 3 lonely electrons and 1 pair of electrons. And carbon has 4 lonely electrons. I'm going to make my dots bigger. Oxygen, 1, 2, 3, 4, 5, 6. Fluorine, group 7A, 1, 2, 3, 4, 5, 6, 7. And neon, group 8A, 1, 2, 3, 4, 5, 6, 7, 8. Notice that dots are next to each other when they're on the top or bottom, and then one is above the other when they're on the left or the right. And the next row is the exact same as the one above it because these elements are in the same group. So remember, go around clockwise for the number of dots, and it should be the same as the group number. 6, 7, 8. Then it asks you to notice any patterns. Well, we just talked about this. The group number matches the number of dots, which are the valence electrons. So looking at this, group 14 is the same as group 4A. Sometimes you'll see the groups labeled differently at the top of the periodic table. Like if I scroll over here, you'll see there are these other numbers, 1, 2, 3 through 12, 13 through 18. So it says how many valence electrons are in each of these. So that just follows the group number. And here it gets tricky. How many bonds will each of these form? Well, the number of bonds ends up being the same as how many lonely electrons there are. So carbon has 4 lonely electrons. It can form 4 bonds, while nitrogen has 3. Oxygen has 2 lonely electrons. Fluorine has 1 lonely electron. And these have no lonely electrons. So carbon can form 4, nitrogen 3, oxygen 2, fluorine 1, neon 0. You might be asking, what about groups 1A through 3A? Well, those are metals, and we're talking about covalent bonds right now. So we're talking about sharing electrons, and that happens with non-metals only. What's the relationship between the group number and the number of bonds that can form? Well, what are you noticing about the group number plus the number of bonds? It's always adding to what? 4 plus 4, 5 plus 3, 6 plus 2. It always adds to 8. Why does nitrogen not make 5 bonds even though it has 5 valence electrons? Only 3 are what I like to call lonely electrons, because the ones that are paired up are already happy. So now, putting this all together, how does hunk 1, 2, 3, 4 make sense? Well, hydrogens can form 1 bond, oxygens 2 bonds, nitrogens 3 bonds, and carbons 4 bonds. And now you know why. There's a little bit more about drawing things in the Lewis dot structures. I'm not going to have us do those because we're going to be drawing the structural formulas where we connect the dots. And then it asks you to look at some different electron sharing. And it says to open simulation 35 in Odyssey, but mine is actually 34. So look for the one that says electron sharing. And when you open this up, you can see that the shape of water is quite different from the shape of ammonia or the shape of the methane, because there are different density clouds around each of those atoms. So your homework here is to finish up the check-in and the homework questions.